Now we're on to part 2 of our 6-foot LED shop light build. Now we're actually going to set the LEDs in place and mount them using the screws that we've got. First step is to grab your LEDs in thermal paste, and we're going to put a little bit of thermal paste on the bottom of each LED like so. And I found this to work pretty good, a 16D nail, a framing spike, and roll it around, smear it around on the back of the LED chip. This stuff is very messy, very sticky, and it's hard to get off your skin, so use caution when you're doing this. Once you get a good amount of that spread around, center it on your marks and press it down. One very important note here is to pay very close attention to the orientation of each LED chip. As you can see in this picture, they're labeled with polarity. There's a positive tab and a negative tab. Pick a direction and make sure you're mounting each LED chip with either the positive tab up or down or whatever. You just want them all mounted the same way with regard to polarity. And this, the reason why will become clear in the next step as you're wiring them. And then using our number 440 by 16 millimeter screws, we're going to attach the chip to the heatsink. And again, as with tapping the heatsink, we want to make sure we're not over tightening these screws. Those threads are very fine and aluminum is very soft, and you run the risk of stripping out your threads that you worked so hard to put in there. So just work your way down and add all 10 LEDs to the heatsink in the same manner. You see here in the video I've got 2 tubes of thermal paste. You only need one. I just had a little extra left over from a previous one that I built, so I was just using that up. Another word of caution here is that thermal paste and really anything you want to keep off of the LED lens. Very easy to get that stuff all over the place, so be careful you don't get anything on the actual LED itself. The purpose of this thermal paste and the reason it's so important is, as we mentioned before, these LED chips generate quite a bit of heat. Using the thermal paste helps to transfer that heat from the LED into the heatsink. The whole purpose of the heatsink is to dissipate that heat as quickly and efficiently as possible. If you don't use the thermal paste and you aren't able to dissipate the heat from the LEDs, they will destroy themselves really quickly. Now it's time to wire up our LED chips, and this LED array we're going to wire in parallel. And all that means is we're just going to connect positive to positive and negative to negative on down the chain of LEDs here. And this is why it was so important to maintain the orientation with regard to polarity of each chip. And we don't want to be crisscrossing wires as we move down the heatsink. So in this example, you can see I'm wiring the positive side of that LED chip right now using a red wire. And the tabs, as you can see the orientation of the tabs, every tab on that side of center on that LED, on that heatsink is all positive. And you can see the negative side is the tab closest to me. As we work our way down the line here, connecting all these like polarity tabs together, I found it's easier to secure the end of the wire as I'm doing here and then clip the wire to length to the next LED. That way you can remove all the slack from the wire and you have nice tidy runs of wire with no extra slack. One of the more important concepts here is that these tabs are obviously conducting electricity. You do not want them to touch that aluminum heatsink because the heatsink also conducts electricity. This is one of the not so legitimate portions of this fixture. You can see I tension those tabs with a flat bladed screwdriver away from the heatsink just as a precaution. This isn't something that would ever pass code, obviously, or anything like that, so just keep that in mind. I mount mine above head, high enough that nobody can touch them. If you're worried about a short circuit there, I would recommend just putting a little bit a dab of hot glue or something like that underneath those tabs. It's just to hold them in place. That way, you know, you can't bend them or touch the aluminum heatsink with them, in which case they would short out. Alright, so just work your way down the light fixture, connecting each LED chip to the next, positive to positive and negative to negative. And once you're done with that, in the next step, we'll be mounting the DC power source and hooking it up to this parallel circuit. Okay, now grab your two 1-foot lengths of 10 gauge red and black silicone wire, and we're going to prep the ends of those, tin them with solder. And as you can see, I have the positive side already hooked up. Right here I am soldering the negative side. And all I'm doing is choosing the LED chip that is closest to the center of the LED fixture. And I'm adding these wires to the tabs on that chip, being careful not to unsolder the wire leads that I've already got there. So you can see the result there. We're choosing this chip that's closest to the center because that's right where our power source is going to mount. And like I said, these wire leads are going directly to the power source. Alright, now we're going to mount the power source to the LED fixture. To do that, we're going to need our two M4-.70 by 16 machine screws. It's pretty self-explanatory here. We're going to feed them into the power source mount holes that we drilled, moving our wire carefully out of the way there. And we're just going to line up the two holes on our power source with those screws and screw them in. They should thread right into those holes. Alright, now flip your light fixture over so that you can access your power source. At this point, we're going to trim the power leads so that they are an appropriate length to reach where we need them to reach there in the DC power source. Leave yourself a little bit of slack, but you want each wire to be able to reach all the way to the top of the power source, thereabouts. That way you know you have enough wire. And then strip about a ½ inch off each wire, and I'll show you in the next step where we're going to install these wires. Alright, while we're looking at our power source, I'll point out some of the features of this one. We've got a pot that rotates, which is the voltage adjustment for the DC voltage output. We've got our terminals here, which we'll go over in just a few moments. And we've also got a fan, which is a thermally activated fan, which means that the fan will only turn on when the unit senses that it's getting warm, which is a nice feature. The older versions of these did not have that. The fan was on all the time. The fan itself is not very loud, which is also nice. You can hear them kick on, and they're really not that intrusive. So all in all, it's a pretty good quality power source for the money. One of the things I like best about this particular power source is the fact that you can control the DC voltage output. LED lights, being diodes, will conduct more current the more voltage that you apply to them. Typically, in a situation like ours, we would use capacitors and so forth to limit the voltage right to the LED's maximum, which in our case is 12 volts. We're going to simplify all that by dialing down our voltage using this power source and keep the LEDs from essentially frying themselves. And we will keep the voltage underneath 12, and I'll show you that in the further down the road here. Alright, once you get your wires cut to length and stripped and ready for hookup to the terminals, we're going to go ahead and take a close-up look at what the power source layout looks like here. So you can see they're labeled here. We have 3 terminals labeled voltage plus, or that's our voltage DC positive. That's where our red wire is going to go. And we have voltage DC negative, and that's where our black wire is going to go. Doesn't matter which 3 that fall in those demarcations, just as long as you got positive to positive and negative to negative. And you can see on the right side of the power source is where the AC power cord is going. There we have ground, neutral, and load. And that corresponds with green, white, and black wires from your power supply cord. In case it isn't totally obvious, do not have your power supply cord plugged in while you're hooking it up. And go ahead and get all your wires hooked up as you see here, and we'll be ready for the next step. I would like to stress to you that this is by far the most dangerous portion of this build. We're dealing at this point with AC power, 120 volt coming out of your household, and that can and will electrocute you if you do not know what you're doing. This power source itself is not designed for this kind of thing. It's more designed to run a ham radio or something like that. You can see the plastic tab down over the terminals is not really, in my opinion, adequate to protect against electrocution. Again, another reason why I hang these up overhead out of the reach of really anybody. So it's important that you know what you're doing when you're dealing with AC power, because it is very unforgiving. So if you don't know what you're doing or you're uncomfortable with it, stop and have somebody who is install the rest of this. Okay, at this point it may be very tempting to plug in the power source and see what your lights look like. Do not do that. We need to first adjust the voltage pot and make certain that we are at the lowest voltage setting. And we're going to do that by taking a small Phillips screwdriver and turning the voltage pot counterclockwise as far as it will go. And we're going to do that very gently. It's very fragile. Once you have that voltage pot turned against that stop, that's the low setting, which should be around 10.5 volts. Again, our LED lights are 12 volt lights. 10.5 is comfortably underneath the maximum, and we should not have any problems with overcurrent and the LEDs overheating or destroying themselves. Here you can see how you can set your multimeter up to do a quick test of what voltage you're actually getting. I've hooked up 4 or 5 of these, and every time the low setting is around 10.3 to 10.5 volts, and that's where I leave it. If you do want to check your voltage, this is how you do it. Use the positive terminal of the multimeter to the positive DC terminal, and the negative terminal of the multimeter to the negative DC terminal of the power source. And you can mess with the voltage pot there and see what you get. I wouldn't run these lights anywhere close to 12 volts. They're all different. One could peak differently than the other and draw more amperage and burn itself out. So 10.5 volts at the low setting is perfect. Now for the finishing touches to our light fixture. Here you can see mine, as I mentioned earlier in the video, that I've drilled 2 sets of holes for the hanger wire. You only need the 1 set. This was way overkill. Using the 18 gauge wire, I think it's rated for 50 pounds, 25 pounds, 50 pounds, something like that. This light can't weigh more than 5. And I also added a zip tie to the edge of the power source there to secure the AC power cord. That seems to help hold things in place. That's really about it. The sky's the limit on how you want to hang yours. I use chains coming off the hanger wire that were existing in my ceiling. Alright, that about does it for our DIY LED light fixture. You've got under $100 and you've got a light fixture that should absolutely put to shame anything else you've got hanging in your shop or garage right now. Let me know how yours came out. Don't forget to comment, and if you liked the video, thought it was helpful, make sure you like it and spread it around. Stay tuned to my channel. I'm going to be doing some other fun DIY stuff here in the near future. Thanks for watching.